Hello everyone, welcome to our physics short video called Physics 101 Soccer Edition,
where we'll be presenting Newton's 3 laws of motion.
Pause. This right here is a clear demonstration of Newton's first law of motion. Let me explain. Boy, I never get tired of that. Now, as I previously mentioned, the first law of motion of Newton states that objects that are at rest will continually stay at rest unless a force is acted upon them. And the same thing happens with objects that have a constant velocity. If there is no unbalanced force acting on the object, then it will stay in its current state of motion. This is a property called inertia, which is basically how stubborn an object is. And the more mass an object has, the more inertia or resistance to change it is. Basically, like I like to call it, the fatter, the lazier. Now, in the FBD below, it's represented the situation that you saw earlier with the ball. Here, my partner Anthony is exerting an unbalanced force on the ball equal to 10 newtons, and it's opposite to the motion of the ball. If there was no force acting on the ball and friction and air resistance were neglected, then the ball would keep rolling away forever, thanks to this guy here called inertia. But since there is an unbalanced force of 10 newtons in the opposite direction of the motion, then the ball is forced to stop. And that's the first law of Newton. Pause. What you're about to see happen right here is a demonstration of Newton's...
You let me take the shot?
It's supposed to be frozen.
Yeah, up yours. Can I take the shot?
Alright, take this shot. Pause. What you just saw happen is a demonstration of Newton's second law. Let me explain. It's even better the second time around. Alright, so as I previously mentioned, mathematically, the second law of Newton states that force equals mass times acceleration. In other words, acceleration is directly proportional to the force applied on an object and inversely proportional to the mass of the object. The more mass an object has, the less acceleration for a constant force, and for constant mass, the more force, the more acceleration. Basically, this means that if a net force is being applied on an object, that object will accelerate. Now, in this case, as my friend prepares to score the decisive open net goal, he inputs a force of 100 newtons on the ball. Now, we know that the net force on the x direction is 100 newtons. So, applying the formula for the second law, which for net force equals mass times acceleration, we solve for the acceleration, which in total gives us 200 meters per second squared. Pretty high, right? Well, I mean, if he didn't score that goal, you wouldn't see him in the rest of this video. Let's go!
Let's go, baby!
Alright guys, thank you very much for watching the video. I hope you liked the video.
Hey, wait. You said there were 3 laws.
Yes, okay. So?
Well, we only did 2.
Right. Third law.
Nah. Let me do it this time.
He's right. That is fun. So, as I just mentioned, Newton's third law is the idea that every action has an equal and opposite reaction. This is shown in this example. Say Albert has a little bit too much of Billy. So, he decides he's going to do the deed. They're on the top of the CN Tower on the edge. Albert puts 50 newtons of force into Billy, pushing him off said ledge. Now, because he put 50 newtons into Billy, there'll be an equal and opposite reaction force of 50 newtons back into Albert. This was shown when me and Timur chest bumped after I made the winning goal. See, I put about 50 newtons of applied force into Timur, so a reaction force of 50 newtons was put back into me. Now, if these forces are equal and opposite, how come Timur went further back than I did? Well, that's because of our masses. Timur has 64 kilograms of mass while I have 73. For this, we can refer back to the first law of inertia, If something has a higher mass, the less it'll want to change state. So, because my mass is higher than Timur, I won't go as far back as he does.
Guys, thank you a lot for watching the video. We hope we're able to demonstrate the three laws well enough for you to understand. Thank you. Goodbye.
What?
Pause. What's about to happen here is a clear bomb.
Banana bidididana.